Good morning. We were talking about cause and effect. Let me briefly recap where we were. We were looking at David Hume's account of cause and effect. Might be a little more precise to describe it as an account of a sufficient cause or a sufficient causal condition. So according to that account, an event E1 of a certain kind causes an event. I'll call this kind K1, causes an event of a certain kind K2 if and only if first an event of kind K1 is always followed by an event of kind K2. So secondly, E1 is followed by E2. And third, E1 and E2 are spatially contiguous. Okay, so there were some problems for this. One problem for condition 2 is when a cause and an effect are simultaneous with one another. Another problem occurs when the cause and the effect are not spatially contiguous. In other words, there's action at a distance, where there's no series of events connecting the two events, but the two events are not next to each other. They might be very far apart. An example that exhibits both of those problems, that is simultaneous the cause and effect being simultaneous and there being not spatially contiguous with one another, is the quantum mechanical phenomenon of entanglement, where two microparticles which are brought into being by the annihilation of another particle, so to speak, a given particle is destroyed and produces these other two particles, which then are said to be entangled because their spins are forever synchronized, even when the objects are very far apart and no signal or causal chain could connect them. They will simultaneously have their spins coordinated, so that if one particle is made to be spin up, for example, the other particle will have upward spin as well. So if you were to change the spin of the particle here on Earth, then its twin particle, if it was thousands of miles away or something, would at the very instant that the spin was changed on its coordinated particle, its spin would mirror the spin that the other particle was changed to. And there couldn't conceivably be any signal passing between the two since they've changed simultaneously. And the fastest signal travels at the speed of light, which would be slower than a simultaneous change, yet they seem to be causally connected. It's a great mystery how that happens, but it seems to be a consequence of our best scientific theories, and it's been experimentally verified. There are hopes to use it to build this phenomenon to build super fast computers, since the processing could occur instantaneously. Right, so that undercuts both 2 and 3. We seem to have a causal connection. The spin of this particle being changed produces the spin of that particle being changed. Happens simultaneously and at a distance. What about the first condition, that an event of kind K1 is always followed by an event of kind K2? Well, the two examples that I just gave challenge the need for conditions 2 and 3. Right? They say that these conditions are not necessary conditions of a causal connection because you could have a cause and an effect that that aren't followed by one another in time, but occur simultaneously, and that they needn't be contiguous because they might be non-contiguous and unconnected by any chain of causes and effects. There's some question, however, about whether condition 1 together with 2 and 3 is sufficient as well. So these are examples of so-called non-causal sufficiency. This is where one condition is sufficient by law of nature even for another condition, but it's not a causal connection between the two things. A famous example of this is the coordination between night and day. So whenever you have night, it'll be followed by day, or whenever you have day, it'll be followed by night. So an event of the one kind, right, it's being daytime, is always followed by an event of the other time, it's being nighttime, or the other way around, because they go in an endless cycle. Right? A certain event of its being day or night is followed by another event of its being day or night, and they're spatially contiguous, say, right? The particular event of daytime on Earth is followed by nighttime on Earth. So you have all three conditions met, but night doesn't cause day and day doesn't cause night, right? Even though they're causally coordinated. So it would seem then that these three conditions are not sufficient for a true causal connection. You can have non-causal or non-determinative sufficiency because day is sufficient for night and night is sufficient for day, yet neither day nor night causes the opposite. What rather seems to be the case is that there's some other thing that causes both to be coordinated, which would be the rotation of the Earth. Right? Seems to cause both night and day and causes them to be coordinated. So there's a problem there for for the regularity, for this kind of account of causation, which is often referred to as a regularity theory, because it says that one event causes another when the latter event always follows upon the former event in a regular pattern. So it's known as a regularity theory, or the regularity theory. Right, so we can see a number of issues with this kind of theory. Maybe they can be gotten around. Seems to be something to this theory for sure, but it also has some serious difficulties that have never been completely resolved to everybody's satisfaction. Put it that way. But very little is in philosophy. But these are very difficult problems to resolve. At any rate, this kind of account, even if we modify it and play with it to try to get around some of these problems, would give us an account of a total cause. Basically saying that an event of a kind K is K1 is a total cause of an event of another kind K2 when and only when K2, an event of kind K2 is always going to be, is always going to follow an event of kind K1, plus the other conditions. So what about the notion of a partial cause, which is actually sort of the everyday notion of causation that we make so much use of, like when we say striking the match causes it to light and so on. Because obviously striking isn't always followed by lighting. It's only what we called a partial cause. It seems to be part of some bigger condition which is sufficient if we proceed along the lines of the regularity theory in answering our question. So how would one answer the question of what is a partial cause or a contributing causal factor? So we were right on the verge of having a look at that question when we ran out of time last time. So now we're going to go to that. So there are two main approaches here for understanding the notion of a partial cause. Basically in terms of the idea of an event being in the context or ceteris paribus, that is, an event occurs and you can assume this context of all kinds of other events. So when you strike the match, lighting follows because, right, there are all these other conditions that are satisfied that we spoke about, right? The match is dry, it's not too windy, match isn't too old, so the chemicals have gone bad, right? It's sufficient, it's struck in such a way that it's vigorous enough to produce the lighting instead of just sort of weakly dragging it across the surface, and so on. So there are two approaches there. One says that in the context, the given event, striking, causes lighting because in the context, or ceteris paribus, the striking is sufficient to produce the lighting. So that's going to lead you to some kind of account that says there's a law of nature and a bunch of other conditions together with the cause, the striking, right? Such that the whole set of these conditions, right, by law of nature, will always be followed by lighting, or is always associated with lighting. right? So that would be a kind of ceteris paribus sufficiency, understanding the notion of a partial cause as an event which ceteris paribus in the context of all the surrounding events will be sufficient to result in the given effect, lighting. So striking causes lighting because striking together with other background conditions and some law of nature, which basically says that if a match is dry and sufficiently struck and not too old and not wet and it's not windy and da-da-da-da-da, it's a law that if you have all this stuff and the match is also struck, then by law of nature it will light. So that's essentially a Humean type account, like the one we just had on the board there. So if we remove the requirements that they must be that the cause and the effect have to be contiguous in space and that the cause must precede the effect in time, if we remove those conditions, then we'd have an account of a partial cause available, it seems, in terms of ceteris paribus sufficiency. That is, an event being sufficient to produce an effect within the context of other events. And we could spell this all out in a formal way, which I'll do in a moment. So that's one kind of account that you could have. The big red flag, one big red flag we have to look out for, of course, is this problem of non-causal sufficiency about night and day and so forth. That's going to be lurking in the wings as a problem for this account of a partial cause too, right? Because it seems like you're going to have that same problem, potentially. So we'll have to keep that in mind and look out for that when we actually have our account up there. The other way to go is in terms of an event being a necessary factor, ceteris paribus. So, as opposed to something that's sufficient. So one might say that a partial cause is any condition which is needed by law of nature in order for the effect to occur, rather than being sufficient for the effect to occur. So those are two possibilities. So on that account, you could say that oxygen being present is a contributing causal factor or necessary causal condition of the match's lighting. In many cases, these two accounts would yield the same results. Right? So the presence of oxygen is also a sufficient ceteris paribus too, right? Given all the other conditions like striking and so forth. But it's also needed as well. So, so both these accounts seem to yield the same result in many, if not all, cases. All right, so how would the account go? Well, so our example is that a match is being struck causes it to ignite, causes ignition. So the match being struck. So that's our cause. Causes its ignition. And as I said, there'll be a law L which says that if oxygen is present and it's not too windy and the match is new and so on and so forth, that if all these conditions hold together with being struck, then the match ignites. So that's a law of nature. Say it's a law is to say that it's in some sense necessary, or whatever, physically necessary, or at least perceived to be such, thought to be such, and that whenever the conditions in the law are met, the consequence will follow. That if the match is struck and all the background conditions are met, the match must light. It's a physical necessity. In the same way that if you release a lead weight, it must fall, right, by gravity, by the laws of nature, provided that it's not blocked and so on and so forth, which would all go into the antecedent of the law, be part of that total cause for the ball falling when it's released. So you're going to have this background. You're going to have these background conditions and this law. So what I'm going to spell out here is the sufficiency definition of causality. I mean, I think that's probably the more intuitive of the two, that a cause is something which is sufficient to produce the effect, ceteris paribus. So let's look at that one. The necessary causal condition will be very similar, but just flipped around, so to speak. I guess you'd be saying the cause is a condition that's needed in virtue of a law for the event to occur. Here you're saying the cause is an event or a condition which, by law of nature, will always produce, will always be sufficient for a certain effect. So here's an example. So C is a cause of E. If and only if, IFF, if and only if. First, C and E are actual. So they're not mere possibilities, they're things that actually obtain or occur. And so the cause and the effect are actual or obtaining states of affairs. And secondly, there is an actual condition D and a law L such that D and L, well, excuse me, C and D and L logically entails E. So the cause plus the background conditions, right, plus the law. Okay, so the cause and the other background conditions, like being dry and new and not being too windy and so forth, all these background conditions, together with the striking and the law, which says that if you have C and D, then you get ignition, right? You get E. Okay? So C and D and L logically entails the effect. Right? Because you have this law which says that if you have C and D, then you get the effect. Right? If you have striking together with all the background conditions, the law says, then you get the effect by law of nature. Right? If a match is dry and new and struck and so on and so forth, then the match lights. That's a law. No exceptions to that. Even though a match may not light when it's struck because it's wet and so forth, we built into the law that it's not wet and it's not windy and so forth. So given all the conditions, the cause, the striking plus the other conditions that obtain in conjunction with L, logically entails the effect of ignition. But, and the idea here is to prevent some kind of trivial satisfaction of this by building all kinds of stuff into D. So it said that neither C and D, neither the cause and the conditions, nor D and L by themselves logically entails E. right? So the cause and the conditions without L won't get you to E. You need L, right? So just striking plus it's dry, the match is dry and it's not windy and the match isn't old and all that won't give you that the match lights unnecessarily, right? You need to have that law too, which says that if all those conditions hold, then the match lights. So you need that in there. You can't get it. You can't get the effect as a logical consequence of just C and D. That's required. And you can't get it just from D and L either. You need to have the striking. So even if the match is old, not old, and is dry, and it's not too windy and so forth, it's not going to light unless it's struck or whatever, zapped with a ray gun, whatever. I mean, there might be other, right? There could be other conditions together with D that will yield ignition as well. A heat ray, a laser gun, whatever, shined at the head of the match, together with the match being new and so on and so forth. So, but it seems clear that you need these two conditions to be met as well. Otherwise, you could have cases where condition D has been jerry-rigged so that you don't really have a causal connection at all, some kind of logical connection, which would make the whole thing trivial. Okay. So this is a sort of basic account of a partial cause. So the intent here is to say that the partial cause is when you have a condition that's part of a bigger condition, which by law of nature leads to the effect. So the bigger condition is C and D, the striking plus the other background conditions, which by law yields the effect as a logical consequence of all of that. Any question before I go on? Now it turns out that even with all this machinery here, the definition is susceptible of being trivialized. It doesn't really get you to a definition of a cause. In fact, you can prove that a state of affairs such as Antarctica's being cold is a cause of the match igniting, given this this apparatus here, given this definition. Antarctica's being cold, which is a completely causally unrelated or causally disconnected actual state of affairs that has nothing to do with the match igniting. Such a state of affairs as Antarctica's being cold, which is logically and causally independent of the match igniting, turns out to be a cause of the matches igniting on this account. That's a significant problem, right? There's something wrong with the whole logical apparatus here to define a cause. It would have to be much more complex for it to work in ways that would involve a lot of metaphysical baggage, I expect. But this won't work. So let's see why that is. So take Antarctica as being cold, right? And what we're going to call that X, state of affairs X. So it's obvious that that's not a cause of the match's lighting, right? It's also obvious that Antarctica is cold. So we have here a true state of an actual state of affairs that's causally disconnected from and unrelated to, and logically independent of and unrelated to the ignition of the match. And we don't want that to turn out to be a cause, but it will, unfortunately, for this proposed definition of a partial cause. So I'm just saying here, proposed definition of a partial cause. Roman numeral 1 is the name of this proposal here. Okay, so X is X, as we've seen, is an actual state of affairs. C is also going to be actual by condition 1 over there, the cause that the match is struck in this case. So C and X are both going to be actual. So therefore, since C is actual, you're going to get that X arrow C is actual. So this is read as if X, then C. And that's going to be true, given the rules for the arrow and logic, which say that if both P and Q are true, then if P, then Q is true. Right, so there's a set of rules for determining the truth value of a conditional if P, then Q in propositional logic, which basically says that such a conditional will be true in 3 out of the 4 possible cases. If P and Q are both true, if P, then Q will be true. If P is false and Q is true, it'll be true that if P, then Q. If P is false and Q is false, it'll be true that if P, then Q. But if P is true and Q is false, then it'll be false that if P, then Q is the case. So there's this one case out of the 4 possible cases of truth value assignments to if P, then Q, or P arrow Q. Okay, and that one case is when P is true but Q is false, then it'll turn out to be false, because you're saying if P is true, then Q is true. So if P is true and Q isn't, clearly if P, then Q is false. But otherwise, it's deemed true. Right, so clearly, if Antarctica is cold, then the match is struck is going to be true, because both are true. Right, so that's going to be true. It now follows that both X and also E are actual, because it's stated over here, required here that E has to be actual as well. The effect that the match ignites, that's also true, or actual. So now we can found that D and X implies C is actual. So D are all the other conditions, right, that you need together with striking to get lighting, right? So it's a list of all those other conditions that are needed by law of nature to get you ignition when the match is struck, being dry and new and so on and so forth. So this is going to be an actual state of affairs here. The conjunction of D and if X, then C, that's going to be actual, because a conjunction is actual when and only when both conjuncts are actual. P and Q is true if and only if both P and Q are true. Otherwise, it's false. Right? If either one or both of the conjuncts of a conjunction are false, then the whole conjunction's false. It's only true in the case where both conjuncts are true, but that's the case we have here, because we've said that D must be actual, because it says here it's an actual condition. And if Antarctica is cold, then the match is struck is also actual. All right. So now we've got an actual condition, D star. And D star consists basically of all of this, right? D star is going to be our old original D conjoined with if X, then C. If Antarctica is cold, then the match is struck. So all the background conditions other than the striking, right, in our law, mentioned in L there, in our law or L, together with this if X, then C thing, right, which is also true, are such that X together with this D star, so let D star equal this. Okay, so there's an actual condition D star, namely that, and a law L, such that X, which is our Antarctica is being cold, right, together with D star, namely this thing. Right. So X and this and L logically entails that the match ignites. Okay. But neither C and D star nor D star and L by themselves logically entail that the match ignites. Okay. You're going to need either L in there or C in there, right, to get E. So it's going to turn out that Antarctica's being cold causes the match to light, which is absurd. So these nasty conditions can still sneak in there, right? To make completely irrelevant things causes on this account. So that's a bad result. And you can get the same problem if you define a cause as a necessary condition of the effect by law of nature. All you're going to need to do is reverse this and make it C implies X, and you get the same story again. Right, because a necessary condition will be, C will be a necessary condition of X when C implies X. So, yeah, so there's a big problem here for this kind of account. Now, even if you can patch this up, there's still going to be the problem, as I hinted earlier, of non-causal sufficiency. So the problem that came up in the case of night and day, where one thing always follows another, but the first thing's not the cause of the second thing. It's an independent thing that causes both. That's the cause of the phenomenon. It's just a correlation, but not causation. Right, so correlation doesn't always entail a causal relationship, even a strict correlation. So another example that we touched on last time of this was the case of the tabletop and the length of the legs, the position of a tabletop and the length of the legs of the tabletop. The length of the legs is a sufficient condition for the tabletop being that length off the ground, so that we can say the tabletop is 4 feet off the ground because the legs are 4 feet off the ground. Ceteris paribus in the conditions, the legs being 4 feet off the ground is sufficient for the tabletop being 4 feet off the ground, given that the tabletop is on top, is attached to the top of the leg. And that seems fine. The problem is that ceteris paribus, that is in the conditions, the position of the tabletop, namely being 4 feet off the ground, is sufficient for the legs being 4 feet long as well. So given all the conditions, right, the fact that that is the relative positions of the tabletop and the legs and so forth. So given all that, the tabletop's being 4 feet off the ground is sufficient by law of nature for the state of affairs that the legs are 4 feet long. So then we'd have to say the tabletop being 4 feet off the ground caused the legs to be 4 feet long, but that's absurd, right? The tabletop's being 4 feet off the ground isn't what made the legs 4 feet long. Right? The legs are 4 feet long because a carpenter cut them to be, made them 4 feet long and so forth, not because the tabletop is 4 feet off the ground. Right? Assuming that the legs were made, say, before the table, right? They were just cut by carpenters at the lumber mill, or for whatever use, right? Which the people making it didn't know, right? Whether they were going to be rafters or table legs or studs in a wall or what, right? They didn't know. They were just making 4-foot long things. Then we couldn't say, right, that tabletops being 4 feet off the ground was in any way whatsoever causally responsible for the legs being 4 feet long. Yet the tabletop being 4 feet off the ground is a sufficient condition, ceteris paribus, in the context of other conditions, for the legs being 4 feet long. Given that the legs are attached, right, and that the earth is 4 feet from the tabletop in all those conditions, they would have to be exactly 4 feet long if the tabletop is 4 feet off the ground. Yeah, so we got a problem there with non-causal sufficiency. This is analogous to the case of night and day, where we have a correlation between two things, but it's not a causal correlation. In this case, though, it's causal in one direction, but not in the other. In the night and day case, it was causal in neither direction. Night was not the cause of day, and day was not the cause of night. But it seems that the legs being 4 feet long does cause the tabletop to be 4 feet off the ground, but the tabletop's being 4 feet off the ground does not cause the legs to be 4 feet long. The cause of that lies elsewhere in the lumber mill and the actions of the woodcutters. Okay, any question on that one? Yeah, so there are some heavy-duty problems facing the defender of the regularity theory in general, and in particular with respect to the notion of a partial cause, as well as a total cause, as we saw somewhat earlier. Right, so at this point we might turn to the idea of the necessary causal condition account. It's going to face some of these same logic chopping types of problems. Maybe those can be surmounted with sufficient ingenuity. Maybe not. But you can always make this more complicated to try to rule out these kinds of examples. But certainly if we go with a necessary causal condition, we don't face that problem of non-causal sufficiency. However, there's another problem we face, which is overdetermination. This is a problem for the necessary causal condition account. According to that account, C is a cause of E when there's a law of nature such that, given that law, it's logically impossible for E to occur given background conditions D that obtain, unless C occurs as well. So C is needed given the background conditions and the relevant law for the occurrence of E. So like oxygen is needed for the match to light when struck by law of nature. It can't light unless there's oxygen. So oxygen would now be a cause, because in the context of the background conditions and the relevant law, oxygen is needed for the match to light. It's not that it's sufficient to make the match light according to the account, but it's needed for the match to light. So the problem with this is the case of overdetermination. In overdetermination, you have two simultaneous sufficient causes to produce an effect. The classic example is a politician being assassinated by being shot. There's a rifleman positioned on a building on the one side of the politician and another rifleman at an equal distance with the same rifle and ammunition on another building on the other side. And they both fire their bullets simultaneously. They're synchronized. And one bullet enters in, say, the right side of the politician's head, right through the temple. And the other one comes in, of course, on the other side in exactly parallel spot. So each bullet will be sufficient to kill the man. So which one is the cause, given the necessary causal condition account? Neither one will be necessary. No, actually neither, because neither one will be needed. See, according to this, it's the condition which is needed in order to produce the effect which is the cause. But neither of the shots is needed, because if this one hadn't been fired, he would have died anyway from this one. And if this one hadn't been fired, he would have died anyway from that one. So neither of the two is necessary. So this pulls us back towards the sufficiency account, right? Because each one is sufficient in the circumstances to kill a man, right? So if we adopt the sufficiency account, we can say that both cause death, because each one is sufficient by itself, given background conditions to produce death. But we moved away from that to avoid the problem of non-causal sufficiency. So then we're saying that a cause is a necessary factor for the effect being produced by law of nature, given the background conditions. And then we have to say that there's neither is a cause, which is bad, because we want to say that both are causes. So this is a nice sampling of the difficulties that confront philosophers trying to understand the concept of causation along roughly Humean kinds of lines. All right. So let us turn to our next topic, which is substance. So I'm going to erase all these equations here. Okay, substance. So what are the intuitive data for an account of the concept, the philosophical concept of a substantial being or individual substance? Well, according to our folk ontology, our everyday conceptual scheme, which we interpret reality, the notion of substantial beings figures very prominently in that everyday or folk ontological conceptual scheme. Substances seem to include ordinary physical objects, such as chunks of ice and rocks. Also, animate beings, such as animals and plants. For example, Rover and Fido and Spot and Garfield, Felix, and other felines, human beings, and so forth. Moving on to the scientific view of the world, we believe that these compound objects, such as pieces of iron and trees and dogs and cats and so on, are composed of smaller parts which are substantial. So you could move down to the level of molecules. So not only are there, say, pieces of gold, these pieces of gold are made up out of smaller units. for example, molecular or atomic units. So there'd be an atom of gold. And the atom of gold would be made up out of even smaller substantial particles like protons, neutrons, and electrons, and so forth. Science tells us that depending on the number and arrangement of these subatomic particles, you get substances of different types. So in one case you'd have gold, in another case you'd have silver. You would get different elements depending on the number of atomic particles in each type of substance. So our overall picture of the world, based on common sense as enhanced by scientific discoveries that we've made, suggests that we have a kind of hierarchy of substances ranging from very tiny to larger and more complex, and the properties of the more complex substances depend on the order and arrangement of the minuscule substances. And maybe eventually at the very bottom of it you get to some wholly simple substance that can't be subdivided. So Wilhelm Gottfried Leibniz argued that if there are complex substances, there must be simple substances, and that we can't subdivide forever. So that's one philosophical view. In opposition to that are those who believe that matter is infinitely divisible. You can go on. In principle or potentially, you would be able to go on forever, subdividing into smaller and smaller particles. The so-called standard model in physics says that there are elementary particles that cannot be further subdivided, but that's our best theory at the present time. It's not impossible that scientists might change their mind about that, however. We've seen many instances in the past where theories have been overthrown and replaced by more accurate theories. So we'll have to await the verdict of time and see if the elementary particle view maintains its prominence. But it's been sort of the dominant view throughout the modern era, without any real philosophical proof that that's the case. Aristotle is among the more prominent philosophers who thought that matter was infinitely divisible, that there were no atoms. He thought you could always subdivide it further. So he would say an electron is a tiny little particle, and we could break that up, and so on. That's not what our experiments tell us. All right. So that's sort of the ordinary picture that we have of substances. It's important within this picture to distinguish between two uses of the term substance, what might be called a stuff sense and a count sense of substance. So we can talk about substance as a stuff or kind of stuff, like gold or platinum. If someone were to ask me, list different kinds of substance, I might say, well, there's gold and copper and iron and platinum. And if I did that, I'd be talking about substance in the stuff sense. This can be contrasted with the count sense of substance. In the count sense, you're talking about substances as individuated individuals that can be counted. So consider the sentence, Mary had a little lamb, from the children's poem. Mary had a little lamb whose fleece was white as snow, right? And everywhere that Mary went, the lamb was sure to go. Right. So Mary had a little lamb. In this sentence, the word lamb is being used as a designator for a substance in the count sense in the original poem. Mary had a lamb, and her friend Susan had a different lamb, right? Had a pet lamb. So there you'd have two lambs, right? So you could count them: Mary's lamb and Susan's lamb, and then there was Sally's lamb, which would be a third lamb, and so on. Right? So we're counting lambs here. But we could take the term lamb not in the count sense if we wanted to, but we could take it in the stuff sense. So if we said Mary had a little lamb in the stuff sense, what we'd be saying is she had a certain amount of lamb, like for lunch. Mary had a little lamb, like 2 ounces of lamb. So that illustrates the difference. So with the stuff sense, you can ask how much, and in the count sense, how many. So stuff sense, how much of it do you have in the stuff sense? How much lamb? How much gold? How much copper? Right? So on. So we're talking about the stuff sense there. The count sense is how many of them do you have? How many pieces of gold do you have? How many pieces of silver? How many lambs are there in the zoo, in the children's zoo? Oh, well, there are 7 lambs in the children's zoo. Aristotle puts out the idea that in the count sense, every substance is a kind of, can be viewed as a kind of combination of stuff with a form imposed upon it. He calls that the form of the thing versus its matter. Both are abstractions from the thing. The thing is in some metaphysical way a unity of form and matter, or form imposed on matter. So if you have some matter in the stuff sense, like copper, you can put a form on that copper and get a vase-shaped piece of copper, which will then be an individual substance in the count sense. So he would say an individual substance in the count sense, that is an integrated, standalone, autonomous, that is to say an autonomous individual, is a complex of form and matter for Aristotle. So matter is matter in the stuff sense. So you could say, how much does the vase weigh, right? So you'd be weighing its matter in the stuff sense, as it were. But to be a countable individual, it would have to have a form. So Aristotle's view makes good sense so long as, certainly so long as we're thinking of matter as having some definite properties. Like if we identify 7 ounces of copper, right, then we're saying that this matter has this property of being made of copper and so forth. And if we analyze what that is, we'll be led to the idea of atoms of copper and so forth. Right? If we ask, what makes it up, which suggests to me that the count sense is more fundamental than the stuff sense. That you ultimately get down to individual atoms of these substances. If you try to make the stuff sense the more primal sense, and I guess one way to do that is to reject atomism, which Aristotle did, as I've noted. But if you don't, you'd have to assume some kind of primal matter which is kind of formless, which Aristotle himself says isn't really possible because you can't have matter without form. If you try to think of featureless matter that has no features at all, it doesn't seem to be a sensible notion. If we take away the fact that it's copper and take away the fact that it has a certain shape and size and so forth, what are you left with? A kind of bare particular with no real qualities. A highly problematic notion from the point of view of logical consistency. So, at any rate, it seems clear that we can distinguish this kind of how much discourse from the how many discourse. And there seems to be, if one adopts an atomic theory of things anyway, an argument for saying that the count sense is the more basic sense of the two. Though without atomism, it's not clear which would be more basic. Any question about the distinction between stuff versus count? So anyway, I'm going to be focusing mainly on the count sense. This seems to be as I've argued, the more fundamental sense of the two, and it certainly has a very prominent role in our thought about the world, which seems to have at its very center our belief in the existence of all of these particular countable objects like tables and chairs and planets and stars and organisms, different people and animals and plants, and all of these things that we see around us, each of which is a separate, countable, individual substance. Right, so there, throughout the history of philosophy, there have been a number of attempts to analyze this notion of a substance, to explain what a substance is. So here we'd be looking at the Socratic question. What is an individual substance? I'll put the word individual here in brackets to indicate that we're using substance in the count sense of individuals. Okay, so Aristotle, who is well known as a adherent of what might be called a substance attribute ontology, saying that the world primarily consists of individuals and their properties. Aristotle has the hope of understanding everything in the universe in terms of individual objects and their qualities, arguing that we don't need anything more than that. And he further holds that, in general, properties depend on substances for their existence. So remember, no canine entity without canines, no feline entity without felines, and so on. So he sees substances, in a sense, as the bedrock of the universe, because although he recognizes the existence of properties, properties existentially depend for their reality on the existence of the substances. So he calls substances primary beings, whereas he regards properties and essences as secondary beings. So Aristotle distinguishes primary substances from what he sometimes calls secondary substances, which are these attributes. If the attribute is essential to the substance, he calls it a secondary substance. When the attribute is accidental to the substance, it may be either a general, what Aristotle calls a general characteristic, or a particular quality. So he distinguishes among properties essences like catness and dogness, general characteristics, and particular qualities like red and green and so forth. All right, so at one point, Aristotle attempts to define a substance as something which can undergo change. He says a substance is something which can admit contrary qualities while remaining numerically one and the same. And by this he means over a period of time. So Socrates can go from being pale to being sunburnt over a period of time. So Socrates admits contrary qualities, being pale and being sunburned at different times. And it's this potentiality for undergoing change that distinguishes, on this attempt, a substance from a non-substance. He says only substances can undergo change in this way. Other kinds of things, for example, qualities, he says, cannot undergo change. So the quality of being pale can't change, although Socrates can. So this is one classical attempt to define a substance in terms of the capacity for undergoing change. A problem with this account, which Aristotle was aware of and addressed, was that qualities could undergo a kind of change. A quality or some other kind of entity. I guess Aristotle's example was a belief or the content of a belief. He said, well, look, Jones can believe that the sky is blue on Monday, right? So on Monday, the fact that the sky is blue, right, is believed by Jones to be true. But on Tuesday, Jones doesn't believe that anymore, so, for reasons. He's hallucinating that the sky is purple or something. Right? So then the belief or content of the belief, which is that the sky is blue, is undergoing a change because it was accepted by Jones on Monday, but it's not accepted by him on Tuesday. So it looks like we have to say that the proposition that the sky is blue is a substance. Right, but clearly it's not a substantial thing, is it? The fact or proposition that the sky is blue is not a thing like a table or a living organism. It's not in that same metaphysical category at all. It seems to be an abstract entity of some sort. In any case, it's clearly not an individual substance, like a table or lamp or tree. Aristotle's answer to this is to concede the point, but to change his definition. He says, yes, non-substantial entities can undergo change. However, the changes that they undergo are relational changes. They're changes in a relationship that that abstract entity bears to some concrete entity. For example, whether a certain concrete entity believes in that proposition or not changes. But there's been no change in the abstract entity itself. That is, the proposition that the sky is blue doesn't change in itself when Jones stops believing in it. So Aristotle proposes that a substance then is something that can undergo intrinsic qualitative change. That is, it can change in and of itself. So when Socrates changes from pale to sunburnt, Socrates doesn't just change in a relationship that he bears to something else. It's not like he's nearer to the wall and then further from the wall. He changes in and of himself. His skin changes color, which is part of him. So he changes in and of himself. The properties of him or his parts change, which is not the case when the content of a belief undergoes some relational change. So Aristotle's definition of a substance can be rewritten then like this, that X is a substance if and only if X can undergo intrinsic qualitative change. An intrinsic quality of the thing can change. This would rule out abstract entities like properties, propositions, numbers, and so forth as substances, because they can never undergo any intrinsic change in and of themselves. Whereas Socrates and other substances would be able to undergo some intrinsic change of qualities. Okay, even this definition faces two challenges, though. It's an improvement over the first one, which just says any change at all would make it a substance. That clearly won't work because of the possibility of relational changes that anything could undergo, whether a substance or not. Two problems briefly. Atoms. It's questionable whether atoms can undergo any intrinsic qualitative change. Take an electron, what intrinsic qualitative change can it undergo? It's not clear that it can. All electrons seem essentially alike. In fact, they're all interchangeable. They have a certain mass and a certain size and so forth, but those can't change. Aristotle, as I mentioned, though, didn't believe that any atomic particles existed, so he would say, well, that's not a real possibility. Clearly a very controversial matter, but so perhaps Aristotle's definition is defensible from the point of view of his ontology, which does not include atomic objects. But it conflicts with modern science, which says there are true atomic particles. That is, particles that cannot be subdivided. So that remains a controversial question. I guess there's also the question of whether absolute motion could be an intrinsic quality of particles. Aristotle, though, believed in a relational theory of space. That answer wouldn't be available to him anyway. Another problem has to do with things like limits, like the surface of a ball, which is a boundary. So the surface of a ball is not a substance. It depends on the substance in some sense, right? So if you have a ball, you'll have a surface, but you can't have that surface without a ball. Can a surface, which is a insubstantial thing, remember the surface can't exist on its own, right? It has no thickness, it's just the surface of a ball. Can the surface undergo a change? Yes, if the ball is squeezed, the surface will change its shape. So any change that happens to the shape of the ball, right, when it changes, will also be a change in the surface of that ball. And that's an intrinsic change in the surface. It's not a relational change. So it seems like Aristotle's definition implies that an insubstantial thing like a ball's surface is a substance, which is incorrect. Here again, though, Aristotle did not include boundaries in his ontology. If you look in his list of categories, he has no category for boundaries. He does believe in substances and various kinds of properties, but that's properties and relations. He believes in substances, properties, and relations of various sorts. He recognizes 10 sorts in addition to the primary substance. But boundaries and limits are not among the things he recognizes. So again, Aristotle is quite consistent. He would deny that limits, like boundaries or surfaces, have any existential status. But many other philosophers do believe that boundaries are needed. So Aristotle's view would be controversial. It seems that in trying to find an account of substance, one should try to have it be as ontologically neutral as possible, that is consistent with as many potentially viable theories about what might exist in the world as you can. So at the very least, Aristotle's theories, account of substance in terms of change, suffers from excessive lack of ontological neutrality. Requires you to accept Aristotle's exact theory of what there is in the world. And on that note, I will stop for today. We'll continue with more on the category of substance, looking at various historic definitions, and then trying to work toward a plausible account of the concept that actually works.